Good day, everyone, and welcome to J.K. Michael's Knowledge Series. Today, we're going to be talking about OEE, Overall Equipment Effectiveness, has a part or has one of the fundamentals of total productive maintenance. But before we go into that, I want us to touch what total productive maintenance is as a precursor, as a beginning point for understanding OEE. Now, let's begin with a very small definition. Total productive maintenance is the process of using machine, equipment, employees, and supporting processes to maintain and improve the integrity of production and the quality of your system. Right? This is a comprehensive approach to equipment maintenance that aims at achieving perfect production. And this means that we want to be able to minimize breakdowns, we want to be able to minimize stops or slow running, we want to be able to eliminate defects and ensure that there is no accident, that there are no accidents, right? So in other words, one of the ways we evaluate systems is that we evaluate the effectiveness of systems on three things: people, processes, and technology. In other words, what this total productive maintenance aims to do is to ensure that we achieve perfect production, whatever that means, right? Or at least as close to perfect production, right? By working on training our people, developing our people, ensuring our processes support effective management of our equipment, right? And then, of course, ensuring that we have the right technology and all our machines and equipment work in tandem to be able to achieve perfect production. Um, and then again, this is not a game of maximizing the number of what you produce. It's part of it. But it goes beyond that. It goes into ensuring that we properly manage breakdowns or we properly manage maintenance so that we do not have breakdowns. We properly manage maintenance so that we don't have slow runnings. With our equipment do not bring out defective products, and we do not have what accidents or injuries on our staff. Right. Now, overall equipment effectiveness is one of the measures or the KPIs that we use to understand or measure how effective or how perfect our production processes are. So it's one of the major calculations in total productive maintenance, or TPM. And OEE means overall equipment effectiveness. It measures how effective we are in using and managing our equipment. It's made up of three. So there are three variables that make up OEE, or overall equipment effectiveness. You could see it as a composite metric. In other words, there are three things you will measure and compound to be able to get your OEE score. The first is availability. In other words, what we're asking is very simple. To what extent was this machine available and ready to be put to use when called upon? That's availability. Availability will start off as 100%, but then we would then measure things like time losses due to equipment failure and subtract them, time losses due to adjustment and setup and remove them, and time losses used to restarting work after break time. When we subtract everything that reduces the availability of the machine, then we have our availability score in percentages. Performance, on the other hand, starts off as 100% as the ideal, and then we will adjust for time losses related to minor interruptions, time losses related to speed, which is, of course, actual versus optimal speed of production, and that will be our performance. And then we have quality. Quality will be measured as 100% minus losses related to defects in production. So if we assume that availability is 94%, I mean, what we're trying to bring out is show how they compound to give us OEE. If we assume that availability is 94%, performance is 95%, and quality is 92%, then the OEE metric will yield 0.90, which is 90%. Availability is 94%, so this isn't quite correct. This is 0.94 multiplied by 0.95 multiplied by 0.92, which will be 82% or 0.82. What does that mean for us? Well, a lot of times organizations will have goals, OEE goals, and they may set OEE goals at probably 85%. Now, you can see that even though 82% might not be the lowest score you can have in OEE, however, if the goals have been set for 85%, then it means that we have underperformed. And that's how we calculate, and that's how we use OEE, right? So what we are going to do next is that we're going to show how we can use OEE to be able to improve our machine performance. And we'll talk about some of the things that can affect us. A little bit of adjustments to these calculations. 0.94 multiplied by 0.95 multiplied by 0.92 will give us 0.82. So that's correct, right? So we'll look at how we can be able to improve equipment effectiveness. And we will have a very small calculations that will help us with that. Now, first of all, let's look at the three variables. The first variable we have is equipment availability. Like I said, availability is simply readiness of that equipment to be put to use when required, right? So how we calculate this is going to be the actual productive time, which is T over the planned or the expected productive time multiplied by 100%, right? You want to be able to figure out what your actual time is going to be. Of course, the planned time minus everything that keeps you unavailable. Things like, setup time, maintenance time, and what have you. All of these things can be able to, or break down waiting for resources to come in or materials to come in for production to happen. All of these can subtract from your planned or your perfect production time. And that will often lead to a situation where your actual production time would be smaller than your planned production time. Now, we also have efficiency, right? So people call this efficiency, some will call it performance, right? We have availability, we have performance or efficiency, and then we have quality. Now, efficiency would be cycle time, which is, of course, our production cycle time multiplied by the number of units that are produced, and then we'll divide that by the time, right? The actual production time, T, which is our actual production time, right? And when we are able to do this, we have been able to figure out our efficiency. Now, all of this will be expressed as a percentage, and that's why you're seeing multiplied by 100. So see cycle time, where cycle time is probably the amount of time it takes to produce one unit in the standard amount of time it takes to produce one unit, and then N is going to be the number of units produced. So the cycle time being 0.5 multiplied by the number of units produced divided by the actual production time that you were provided will give us our equipment efficiency or our equipment performance. And then finally, we have quality. Now, even after we produce even after we have produced our number of units, we want to understand the rate of quality by taking the number of units produced and removing Q, right? So N minus Q all over N. So the total number of units produced minus defective products over the total number of units produced, and that will give us our rate of quality, right? So these three variables will be multiplied together to be able to give us our OEE, or overall equipment effectiveness. And we're going to see that being put to use in a calculation right now, right? So let's go. We have an exercise at hand. We want to consider last week's production data for a machine. Our scheduled operation was 10 hours per day and 5 days per week, right? So we have 10 hours per day and 5 days per week. That's a scheduled operation. So which is going to be our perfect production time, which is the planned production time, right? And then we have a manufacturing downtime due to meetings. I mean, these were the times we were not able to use the machine in spite of the planned production time. Due to meetings, material outages, trainings, breaks, and faults, it came to 411 minutes per week, right? But we have, of course, scheduled maintenance. During that period, if we have a scheduled maintenance period, then we will obey it, right? Both scheduled maintenance and equipment breakdown, downtime would all contribute to downtime. So in other words, we have 414 and 227 as periods in that week that we were not able to use the machine, right? Now, the theoretical or the standard cycle time, we'll use this to calculate efficiency, is 0.5 minutes per unit. So it takes us 0.5 minutes to be able to create 1 unit. And then the production for the week was 4,415 units, 4,450 units. This is the production we made for the week. And the defective parts created, which will be needed for calculating quality, will be 15 units. We're going to assume an OEE target of, so in other words, management has set a target for us to meet, and that target is 85%. So let's walk through this together and let's see what we can learn from this. Let's go on with the calculations. Okay, we've taken the information now, and then this is it put out. And then we'll consider last week production, right? This is all the data from the last that we read a couple of minutes ago. Okay, so let's run our calculations, right? This is the data we spoke about. Now let's go on and do this. Now look at this. We have availability. You could call this productivity or efficiency. Let's call it efficiency in percentage, right? And then we have quality, and OEE will multiply across. Now let's look at the data and let's calculate. Calculate the last week's, so consider last week's production data for a machine. Scheduled operation is 10 hours per day. So 10 hours per day, scheduled operation time is, we put 10 for hours per day. Days per week, quite simple, we put 5. And then hours per week, 10 hours per day. Also, hours per week will simply be 10 hours per day multiplied by 5 days per week. So hours per week will be 50. Now, the calculations will be done in minutes per week. So our OEE will be computed in minutes. So we'll take the hours per week and we multiply by 60 to be able to get our minutes per week. So in a week, our planned production time will be 3,000 minutes every week. Now let's calculate our downtime, right? We said we had the manufacturing downtime, which is due to meetings. This is just apart from trainings, right? This is just inefficiency, apart from maybe some kind of meetings. You see material outages and maybe excessive breaks. It means that your manufacturing downtime is not good at all. We're looking at 414 minutes per week. Thankfully, that was provided in minutes, so 410 minutes per week. So we have 410 minutes per week. Now, we also have scheduled maintenance. Scheduled maintenance is great, right? But we also have equipment breakdown, downtime. So we have two sources of downtime, manufacturing downtime, and then maintenance and breakdown downtime. And this comes up to 227 minutes per week. 227 minutes per week. So our total downtime in minutes per week will be the manufacturing downtime plus the scheduled maintenance downtime, resulting in 637 minutes per week as our total downtime. Now let's look at the total cycle time in minutes per unit. Now we produce the theoretical or the standard cycle time is 0.5 minutes to produce 1 unit. So we have 0.5 minutes per unit. And then the total number of units produced came up to 4,450 units this week. So 4,450 units this week. So the total standard time, right, for producing these units will be 4,450 units multiplied by 0.5, and that gives us 2,225 units as the expected number of minutes to be able to produce 4,450 units. So now that we have determined our total standard cycle time, in other words, what would be expected to produce 4,450 units of products will be 2,225 minutes. Then let's go on with our calculation. Now, the scheduled operation, now we have scheduled operation time. Now, scheduled operation time is our actual plant time. And that is the perfect availability, right? The ceiling for availability. And we agreed that scheduled operation time would be 3,000 minutes per week. But our actual operation time is pretty shaky. Our actual operation time will factor the time we lost in with respect to manufacturing downtime and scheduled maintenance downtime, and breakdown time. And then the total downtime will be 637 minutes. So our actual operation downtime will take our actual operation downtime will take our perfect, let's call it perfect schedule operation time, and subtract from it the downtime. So this is the operation time without any downtime, and we'll subtract downtime. And our actual operation time comes to 2,363 minutes per week. So we're provided or we're scheduled to operate at 3,000 minutes per week. But when we subtract the impact of the downtime on our operations, then the actual time we worked, the actual time the machine was available was 2,363 minutes. Our availability in percentage would be that we'll take this actual production time and we'll divide it by the scheduled operation time, which is the time we originally planned to get this work done. And this gives us 78.8% availability. So we have 78.8% of availability. Now we can take this up and we can put in our availability score as 78.8%. Now we have that covered. Now let's calculate our efficiency, or you could call it productivity, right? Now, what is the standard cycle time? Our standard cycle time, we said, was going to be what? 0.5 minutes to produce 1 unit, right? And I think we can just pull this down because we've already entered it. 0.5 minutes to produce 1 unit. And then the actual operation time was what? 2,363 minutes per week. And then the standard number of units expected would be the actual operations time multiplied by 0.5. And that is our expected standard number of units, right? And then the actual units produced was, the actual number of units produced is 4,000. Okay, let's determine our productivity or efficiency, however you choose to call it. Productivity, let me put a bracket in case your brain keeps saying efficiency, but we're speaking the same language. Efficiency. All right, let's measure our efficiency. Now, the standard cycle time in units per minute, how many units we want to produce every minute, right? Or how many units we produce in a minute, right? We have what? 0.5 units produced in a minute. And then we have our actual operation time being, I think I'm just going to start this second version totally. I don't think